I try to make it as much about the core offline first topics and how I use CouchDB. But it will go a bit into the other details too. And nice. Then let's right into. I wanted to catch you all. So it's kind of a follow-up to Alex. Two things. I think this article was either Alex or Jan, correct me, because it went offline last week. So I'm catching up on the real-time patterns talk of Alex and also the offline first to-do list with Svelte and PouchDB, CouchDB neighborhoody blog post. So that's what I assume you all looked into. If not, then maybe the blog post will come online again anytime, or maybe there's similar things online. So I won't go through the very basics like changes feeds and stuff like this, but go more into the real world problems that I faced moving these things from these talks and all these experiments we probably all did with CouchDB to real world applications that are offline first. And I also wanted to catch up on Jan's I think in 2012 or so, he coined the term dream code, and I really love it. I didn't hear it in a while. And this is how I really love to think about developing APIs or folder structures for frameworks or some things where it makes sense to forget what you know about technology constraints and try to reimagine just with an empty editor what can be done. And this is my first approach that I want to go through, and then I will go through the real-world constraints of the offline first app and try to merge both to see what's possible and how to do it. So as I said, I'm back from the 10 years ago CouchApps movement, offline first, and there was really exciting developments there. Like we were the original Edge architecture in a way, right? Before even Node.js and all of these developments that are now catching up on what we did back then. And I think it's really exciting, but also, of course, I see a lot of communities going through the same mistakes now. And but there's, of course, new technologies and also new kinds of approaches. So it's really exciting, but I want to all invite you to also join like new local first movements that are nearly identical to offline first movement back 10 years ago, and also put the word out for CouchDB, because I noticed that some of those communities have CouchDB not on the first point when they think about all these topics, and that's really sad, of course. And so I try to put the word out. So we have products that came out since CouchApps were like Hasura, Superbase, Apollo, Firebase, so all real-time heavy frameworks and software as a service backends, all focus on having HTTP first APIs, and also to do a lot of things in the application layer that are hard to do, like caching, batching your requests, selecting the sub fields from documents that you want to get through the internet so it's faster, and doing updates and validation, all these kind of things. And of course Firebase, which is in some aspects quite similar to what we can do with CouchDB, but of course proprietary, and we don't have to look too much into that if it's proprietary. What happened technology-wise, not product-wise? So of course most of these products are GraphQL based, which of course I think a lot of us maybe thought about how you can marry GraphQL with CouchDB, but for me, I always found that it's a really bad fit. We have a schema-less database, and GraphQL doesn't really work without writing your GraphQL schemas. I use CouchDB partly because I want to just join developing and not think about writing a schema first, right? And also, I don't want to have a library that relies on parsing complex query strings and having a relatively rich query language that then has to be mismatched to your other services that you fan out to later. And your DB queries, it's easy to use GraphQL in a bad way, and it destroys your performance and all of these issues because it's quite powerful, and there's no easy solution for this. Then we have CRDTs and a lot of like new technology backends that rely on CRDTs, and of some of the more mathematical follow-ups to operational transform for real-time editing. I just wanted to remind us why we are so excited about CouchDB, because CRDTs and most of these technologies converge, and yes, they sync with maybe a bit less conflicts. But the thing is, it's easy to converge to something that doesn't make sense. And only approaches like CouchDB or Git or like anything that has similar constraints to the merge logic allow you to always have the say in the application layer to make sure nothing gets lost. And I mean not logically lost, because CRDTs can converge to something that doesn't lose data but still loses information. For example, you mark a to-do as done, and another person renames the to-do and adds something to the to-do. So the CRDT converges to a done to-do that contains information that was not done. So this is a logical information loss. And this is, for me, always something I need to explain like every week or every other week now, that we have all these Hacker News posts about these new technologies, but if you looked into them, they don't really replace what we do. And also, I wanted to remind us that auto-merge and CRDT libraries, that you can serialize to JSON back and use it with CouchDB for certain subparts of your application data, and use it where it makes sense. But for a general application layer, I don't think it makes sense. So that said, it makes talking about what we do much harder now. Back 10 years ago, we could talk about it and we could show what cool things we can do. And now we also have to say why these hipster posts are not really solving application layer needs for data that's important. So help me talk to all these people. And also, there's a new follow-up movement that has nothing to do with the original offline first movement called local first movement. And I really like the name because it's not the offline. People always say, but I'm never offline, and local first gets rid of that. But there's a huge part of CRDT peoples, and so it's a bit more different kinds of backgrounds than the offline first movements. I invite you all to also join these kind of things if you're interested in local first application development, and bring more CouchDB background. So today, what do I want to do? First, look at the to-do mini app from the blog post with a dream code back of your head, and try to say what's the least code that we can get away with to implement this, and still not being magic. So magic is always if you got rid of too much, and then add back stuff from my real world requirements I talked about, and talk about how I approach these things. So first of all, what do I do? What do my offline first applications do? So first of all, I worked on some platforms for customer support, like flight agencies use my software as an email client, basically with customer support features. So there's a supervisor that is a manager and has a mobile PWA and is in the elevator and has to reply to something or just make a decision that needs to sync, even if he's like just on his mobile phone for a second and makes a decision. Then we have agents that are in a special workroom with big multi-monitor setups and have multiple browser windows for the same application with different kinds of customers and different kinds of focus views. And so the application needs to be open relatively quickly, but more importantly, it's open all the time, and it needs to be open in multiple browser tabs, and it needs to react well to bad internet because of the bad Wi-Fi in the office buildings for managers and things like that. And the data is also, of course, much, much bigger than what fits on a device or what should fit on a device. So there's a huge database server for the whole group, but every agent and supervisor has a view into this big data. And also, I use this for my own as an email client and things like that. So then, of course, I have all my email history and have on my device like just recent things that fit on my machine. So, I mean, it's like 3 gigabytes plus email data. And this is basically the requirements. Let's have a very quick look at some problems that we have. First of all, a recap of the blog post. Basically, this is more or less it. You have a full sync of the PouchDB to the CouchDB server. You can filter, show all to-dos, show completed, open, and sort by completion time and the text. And it syncs to CouchDB. So if I open this, you see that it syncs in the background. This is through the network. So this is basically where we start. Now to some problems for my use case. So you see I made a backend with a bit bigger number of to-dos. And it's synced right now, and it loads fairly fast because it's all local. If you look here, it's 2.5 megabytes, and this is doing in-memory sorting. So, of course, you would have to add a significant amount of view data if it has views for this. But if we delete this and refresh, then you see you need to wait like 10 seconds or half a minute max to get to something. If you require these done to-dos, you don't have really an influence on the sync order when things come in, so you need to wait. So this wouldn't work for incognito or something like this for my use cases, obviously. Another problem is I have now the same tab open twice, and if I load it here, and you see here, you get errors because you have multiple tabs trying to open the PouchDB. And there's like RxDB and things like that. And there's also other solutions, but RxDB syncs the browser tabs and elects a leader and things like that. So I didn't find that so elegant, and we will look into how to solve this issue. So you see, if I sync here, let's put all this done, and I go to this tab, it's not synced. I need to reload to make it work. So yeah, and you saw the initial delay, and also if I have like in theory, if I make this work with multiple tabs, and I have instance reuse, it wouldn't work because of course every tab has its own instances for everything. Let's go check if there's something. Okay. So, and that brings me to going into the application. So what I like, we can ignore the CSS. You see, I got rid of all Node.js, so it's just the minimal that the application can work. We can't make the index HTML any smaller. This can't be any smaller without being magic, because magic would mean like the application framework automatically launches one app and binds it to the body or something, but then you lose control. So this is what I would consider the minimum to launch an application without being magic. And the to-do item itself has no logic. It just forwards back to the main application. I mean, we can maybe remove the dispatchers, because it's just one layer of nesting of components, so we can just bind functions directly, and we can do debouncing in another layer, because if you have multiple tabs, if you debounce in the components level, then they still could, if there's multiple things working on the same data, it's better to debounce the things that are there for debouncing the database access on that layer. You can, of course, debounce something, but maybe just use a blur event or something like this. But there's nothing to see here. So we go into the application itself. So first of all, of course, you can't really use the database in the browser, or you shouldn't really have to, because yeah, usually you have one database and a couch that you sync with, so that can be quite handled on another layer. Then the sorting doesn't work for big database views, because you don't know what the database server has, so you have to use views for these kind of use cases. And so this all goes away. Then wouldn't it be nice if also the updating works automatically, and I don't have to update manually, and maybe don't have to save, and remove all of this. So then we have the initial fetch and the basically the data lifecycle that should also be taken care of, and we end up with something that is just the minimum template basically. So how then do we structure our to-dos? Like, we can start with something that has an object with my views, for example, all, and here I have my sorting keys, and then something like that. So basically, this is my dream minimum structure that I would like to reach. And let's see if we can achieve this. So first of all, to be able to like know what the application needs, like the data needs of the application, there's many approaches. So first, what the effect is of this is now my query, because I don't have anything that tells me what data is used in what way. So basically, if you know GraphQL, you can think of it like a GraphQL query where you have nesting of different things. You have this each loop and a nested access to this. And of course, there could be many ways to implement this. Basically, you could write a own parser for templates and then generate your queries or something like that. But the problem is that template strings are basically all JavaScript expressions, and you would have to write that. So there's basically only one way to do this, and that's JavaScript proxies. I just want to give a quick demo. So if you know ECMAScript proxies, they are like a wrapper around an object usually, and they allow you to see what access happens. So if I have a proxy, and it should actually so this doesn't exist, so like this can be anything. I created this deep proxy library, so you can just add whatever, not numbers. You can just add whatever you want, and it will intercept and see what happened. This is a set operation on this key on this object, basically. And if you just read it, you will get proxy information. That a get operation happened. With this, we know what our templates tries to access, and there turns out to be a great library called Falcor that's schemaless, but no GraphQL. This is feature-wise very similar. You just have the difference that it's schemaless, and you access the data by using path expressions, and it turns out a path expression looks exactly like the result of this proxy. So you can hook up a Falcor model that runs inside of a service worker, and you can hook that up to the proxy object, and then you generate all your queries automatically. So this is basically how, here's my presentation. This is basically how the data access can be made work with this minimal code that we showed. So how would that look? Basically, we have the same to-do application, but we import a data store, and we just do our key access like we used to. The only difference is we have to terminate leave access with a dollar, because otherwise the JavaScript proxy would not know when your actual value access happens. Everything else is as minimal as we showed in the removed version. Really nothing fancy happens. The only difference is these terminations of value access. And let's see, I don't know how much time I have left. How much time?
It's been 25.
Okay, so I need to hurry a bit. Let's check. Okay, no new messages. So Falcor, as I said, works with these same key expression that are results of the proxy. And if we access this, we have something like a router, And this router works like routing of the web apps that use the URL bar, but for the data models. So basically, what Falcor does is create a virtual giant object that merges your complete database into your application logic. And that's basically how this implementation works. As you can see, it loads quite fast. And if I have an incognito window, and also a normal window, now I have two windows talking to the service worker and one using the network. And you see one window is synced immediately because it's using message passing. The other one uses the network. And I don't have to care for it. So what other approaches do follow? I just wanted to quickly show the architecture of this. So basically, you have the browser tab, you have a Svelte store that's just behaving like any Svelte store, but inside of it is a JavaScript proxy that can see any access to this virtual object that happens and forwards this to the Falcor model, which has a cache. So you have immediate access to the same data. So if I switch now, it's immediately there because it's cached. You have the message channel to a shared service worker that has a router, which accesses Couch, but the offline feature works if it's offline. You see, it just shows what it has offline and uses PouchDB, but if it's online, then it always uses the CouchDB backend for views. The views just return IDs, and all IDs are synced through PouchDB. So it doesn't do an initial sync. So if I delete the database, the cookies, and I log in, so you saw it's quite fast. So it doesn't use all the data. It just synced what is in this view. So now this view is local, and the data in this view is local. But if I load more, then if I go offline, now I can also load what I had offline. So this is basically trying to have the best of both worlds without being too complicated. Yes, so the replicator does exactly that. It uses servers and events and syncs everything I already have in my database. Everything else it throws away, and it has to also invalidate, of course, the things. What other solutions and problems did I encounter with this? So first of all, I sync always what's new in after my initial application load. So I don't have to really decide and have complex logic to decide, which means that after I use an application for a while, it can grow big, but then I just delete the database and start fresh because there's no initial sync. It's quite cheap, and this is really simple to reason about. But of course, if you have a value in your documents that is similar to last accessed or when only recently written stuff makes sense, you can also have a purge logic. Views only return IDs, and all docs are fetched through PouchDB. And merge of PouchDB and CouchDB views is usually not worth it. It's really complex. So it's easy when you're online, you use Couch. When you're offline, you use Pouch. If requests fail, use Pouch. With the timeouts, it's fine. Usually that's all that's required to decide, apart from timeouts, when to fall back based on connection quality is also usually not much worth the effort. And you need to invalidate your cache, the memory cache. This one that's in the browser tabs. And usually I just invalidate everything and then it flickers. But if you want to be really fancy, of course, you can use deleted flags so that you see everything better in the changes feed, and then decide if your view functions changed by the incoming change, and then and then just invalidate that path. Then yeah, we are done. Then issues, of course, difference in sort order. For example, you have to remember if I sort by text and I go offline, you see there's different to-dos on the top because PouchDB and CouchDB have a different sort order out of the box. I'm sure it's possible to fix this, but of course a user that sees to-dos disappearing just thinks your app just lost to-dos. So this is really important to keep in mind. Usually I just don't sort by text. So to get this done, if you look at the views that I needed, it's quite 1, 2, 3, 4 for the invariants. This is, as you can imagine, usually not a production setup. You would remove the feature for one sorting maybe, to have a bit more reuse of the views, which is important, and also to have less updates to do and things like that. And conflict resolution is also for a next talk, and because of these different fetch steps, if I go to slow now instead of offline, you see now, you see now it's loading first the number of to-dos, and then it loads the view, and then it loads the individual documents. So there's these 3 steps, and this can of course lead to a bit jumping of views. So you need to consciously decide what is your layer where you want to have a load as a block. Otherwise you have these jumpy when it's slow, it's fine, but if it's very fast, you have this weird jumpy behavior. So you need to have your loading boundaries well in order. And just a quick outlook, types and JSON schema integration can of course optimize this, but what I wanted to also show is quickly the accounts, basically, because like an offline first system needs also accounts that support this, because now your browser has stored all the data. So I started thinking about how accounts work with offline first. So for example, if I go offline and I change the data, now you see I have a notification that I have 2 local unsynced changes. So I know I can't delete my database and my account from my device without losing data. If I go back online, then this should disappear. Maybe it doesn't work right now, but yeah, so it synced it now. Now I could delete this, but you also see you expose the information, how much you have local from your complete documents in the database, and you also have to take care of your local device resources. And I think that's it. Thank you all.